So in the previous lecture we discussed about some of the basic steps for the filtering in the frequency domain, that are the preprocessing step which may capture the image, that is fx comma y, then the Fourier transformation, one dimension either the two dimensional Fourier transformation is to be applied to get the desired output, and the filter function is to be applied, and we can also take the inverse of the Fourier transformation. Now the question arises how we can get these values. So algorithm is to be used for filtering an image in the frequency domain. So we already cleared that the Fourier transformation is to be used here. So the filtering of an image fx comma y work with these steps. So we have to compute the centered DFT. First of all, we have the image in the spatial domain fx comma y. We can also enhance that image in the spatial domain. Even the enhancement in the spatial domain, if we want to enhance the image in the frequency domain with a different time interval with the different frequency values, then the first step is to compute the centered DFT. So that fu comma v is equals to this symbol represent the transformation, so or the Fourier transformation. So this fu comma v, we get the value by multiplying the original coordinate values of an image fx comma y with -1 par x plus y. x प्लस वाई, फॉर एग्जाम्पल x एंड y की वैल्यू कुछ भी है, 5 × 5 है, 5, 5 है, तो 5 + 5 10 -1 पावर 10 के साथ उसे ओरिजिनल वैल्यूज़ को मल्टीप्लाई करना है. फॉर एग्जाम्पल द इमेज साइज इज़ 500 × 500, सो 100 साइज है. तो जो भी ओरिजिनल इमेज में ग्रे लेवल वैल्यूज़ के हिसाब से हमारे पास टोटल वैल्यू आती है, उसको मल्टीप्लाई किससे करना है, -1 पावर x प्लस वाई के साथ. After that, first step is this. After that, compute G, capital G, U, comma V. That is the output image, enhanced image in case of frequency domain, that we get by multiplying the original image f u comma v with the filter function, that is h u comma v. So the third step is compute the inverse of DFT. Inverse we get by taking the inverse of Fourier transformation. So last part is obtain the real part of the inverse of the Fourier transformation, that भी value we get उसका real part अलग से कर सकते हैं, and compute the filtered image gx y is equals to last filtered image कैसे आएगी, with multiplying the inverse of the real part of the enhanced image with the multiplying with the -1 par x plus y. So we here see that the inverse DFT is a complex value function. When fx comma y, the digital image, is real, then the imaginary part of the inverse DFT vanishes. Clear? यहाँ पर हमने real part क्यों लिया है? When the image is real, then the imaginary part of the inverse DFT vanishes, कि ख़त्म हो जाता है. Thus for the image step 4, a verb does not apply. So if we see that here the fourth step is obtain the real part, but in case that if we get the image is real, then the image part is already vanishes after taking the inverse of the Fourier transformation. So there is no need for the fourth step. So we have the 4 steps. If we are not considering this step, real part, obtaining the real part, because we already get the real part when we are taking the inverse of the Fourier transformation. So these are the steps for filtering an image. So next the topic is of what are the various filters that are to be used for filtering in the frequency domain.